Welcome to an example of classifications of functions such as 1.1 function, 1.2 function, bijections, and invertible functions. Check the injectivity, that is 1.1s, and surjectivity, that is 1.2, of the following function. One part. F is defined from set of natural numbers to set of natural numbers given by f of x equal to x square. Here domain and codomain both are given to be natural numbers. For each x, the image has to be obtained by this rule. The rule is f of x is equal to x square. That is, image of 3 is 9, image of 2 is 4, etc. The square is the image. Let's see whether it is a 1.1 function. The definition of 1.1 function. A function defined from set A to set B is called 1.1 function or injective function if distinct elements have distinct images. If two elements are unequal, their images should also be unequal. It's quite obvious. Two different natural numbers, their squares also will be different. But just by expressing that it is obvious, we are not proving it. We need to prove it by using representative elements or general elements. The definition of 1.1ness is interpreted like this also. That is, in case two images happen to be equal of some x1 and x2, in case two images happen to be equal, that is, if f of x1 and f of x2 are equal, that should imply that the pre-images x1 and x2 should also be equal. Let's check. If possible, let f of x1 be equal to f of x2 for some x1 and x2 of the domain natural number. That means f of x1 is x1 square, f of x2 is x2 square. So this step implies that x1 square is equal to x2 square. Now if you go very casually, one may say x1 square equal to x2 square, so x1 equal to x2, but which is not always true. Here, simplify this equation further as x1 square minus x2 square is equal to 0 and factorize this polynomial. The left hand side is being factorized as x1 minus x2 into x1 plus x2 equal to 0. There are two factors whose product is equal to 0. This can happen either ways, when the first factor equal to 0 or the second factor equal to 0. The first factor equal to 0, that is x1 equal to x1 minus x2 equal to 0, gives you x1 is equal to x2. And x1 plus x2 could also be 0. In that case, x1 must be equal to minus x2, only then the sum will be 0. Now, here, this x1 and x2, one of them positive and the other one's negative is equal to the first one, not possible as x1 and x2 both are natural numbers. A natural number x2's negative is a negative number. That negative number cannot be equal to another natural number. So this case is ruled out. Hence the only possibility is x1 equal to x2. That means whenever two images are equal, that will surely imply the equality of the two x1 and x2. No second possibility. This is the only thing it can be implied from here, which is very well fitting with the interpretation of the definition 1.1ness. Hence we say this function is 1.1 function. To check whether it is an onto function, let's see what is onto function definition. A function f defined from set A to set B is called onto function or surjective function if for each element y taken in the codomain, there exists at least one x in the domain such that the image of that x is equal to the y taken here, such that f of x is equal to y. Let's begin. Let y belong to the codomain, the set of natural number. Let's begin with this. And if possible, let this y be equal to x square for some x. Now, the question is here whether this kind of an x is possible, whether this kind of an x is possible to be in the domain. To see the second stage, there should at least one x in the domain of the function. Now let's calculate what would be x if y is equal to x square. X is equal to square root of y. Will the square root of y, when y is a natural number, its square root, any natural number square root, x need not be another natural number. That is, any y that is taken here, that y, if it is x square, that x will be square root of y. That square root of y may not be an element of the set of natural numbers. Therefore, what we tried saying, if possible let y equal to x square, is not possible for the x in the set of natural number for every y. Hence we say the function is not following this definition. Hence this function is not on 2. This fact we could just express through an example also. As a counter example, let me take, say y is equal to 3. Now if y is 3, is there some x like this? Try. 3 square is equal to, x square is equal to 3. Is it possible? X will be root 3. Then that root 3 will not belong to the domain. There is no x in the set of natural numbers. In set of natural numbers, there is no x whose image can be 3, whose square can be 3. There is no x in set of natural numbers, the domain for which x square could be 3. Hence, it goes as a counter example. Therefore, we can say the function is not 1-1 function. Either of these ways we can prove. This procedure is called general element method, and this way of proving is called counter example method. Either of these will do, either this proof or this proof. The function is not on 2.